Welcome back, dear students, to the third part of our lesson, orthogonality. By the end of this video, you will be able to define the dihedral angle formed by two intersecting planes and list the steps that are sufficient to determine such angle, as well as list the theorems concerning the proof of two perpendicular planes. Before we get started, please prepare your textbook, pens, draft paper, your copybook, and your geometry set. First of all, what is a dihedral angle? Well, the definition states that a dihedral angle is the angle formed between two intersecting planes. To determine the dihedral angle formed between two planes P and Q, denoted by P, Q, first of all, we should find the line of intersection D of P and Q, as you can see in the figure. Let I be a point on D. From I, draw in P a line IX perpendicular to D. Let A be a point on IX. From I, also draw in Q a line IY perpendicular to D. And let B be a point on IY. The dihedral angle formed between P and Q is the angle AIB, as you can see in the figure. Please note that two planes P and Q form between them four dihedral angles. Example 1. Consider a tetrahedron ABCD such that ABD and ABC are two right triangles at A. Determine the dihedral angle formed between the two planes ABD and ABC. Well, this is our plane ABD, and this is our plane ABC. As we said before, the first step is to find the line of intersection of these two planes. Can you guess what the line of intersection is? Correct. ABD and ABC intersect in line AB. The second step is to find two lines in each of these planes that are both perpendicular to the line of intersection AB at the same point. As you can see, line AD is a line contained in the plane ABD that is perpendicular to AB at A, since ABD is a right triangle at A. Similarly, AC is a line contained in the plane ABC that is also perpendicular to AB at A, since ABC is a right triangle too. What do you think the dihedral angle is? Well, the dihedral angle formed between the two planes ABD and ABC is the angle DAC. Application 1. Consider a regular tetrahedron ABCD. Please note that all the faces of a regular tetrahedron are equilateral triangles. I is the midpoint of the edge CD. Determine the dihedral angle formed between the two planes ACD and BCD. Please pause the video and give yourself some time to think. Well, the line of intersection of these two planes is the line CD. As you can see, AI is a line contained in the first plane ACD that is perpendicular to the line of intersection CD, since the median is also a height in an equilateral triangle. Similarly, BI is a line contained in the second plane BCD that is also perpendicular to the line of intersection CD at the same point I and for the same reason. Thus, the dihedral angle formed between the two planes ACD and BCD is the angle AIB. Now moving on to our last objective, perpendicular planes. Definition 2. Two planes P1 and P2 are perpendicular if their dihedral angle is right, as you can see in the following example. Property 1. A plane is perpendicular to another plane when it has a line that is perpendicular to the other plane. For example, this is a plane P, and this is another plane Q. D is a line contained in the plane Q. If the line D is perpendicular to the plane P, and D is a subset of plane Q, then we can say that the plane Q is perpendicular to the plane P. Property 2. If a line D is perpendicular to a plane P, then any plane containing D is also perpendicular to the plane P. If this is a plane P and this is the line D perpendicular to it, any plane that D is contained into will also be perpendicular to the plane P. Example 2. Consider a regular tetrahedron ABCD. I is the midpoint of the edge CD. Show that CD is perpendicular to plane ABI. Now remember, to prove that a line is perpendicular to a plane, we should prove that this line is perpendicular or orthogonal to two intersecting lines in this plane. Is CD orthogonal to AB? Is it perpendicular to AI, to BI? Well, this is the plane ABI and this is the line CD. AI is perpendicular to CD since a median is also a height in an equilateral triangle. Similarly, BI is perpendicular to CD since also BCD is an equilateral triangle. AI and BI intersect in point I, thus we can say that line CD is perpendicular to plane ABI. Part B. Deduce that plane BCD is perpendicular to plane ABI. Now remember, to prove that two planes are perpendicular, it is enough to prove that one plane has a line that is perpendicular to the other plane. We proved in Part A that CD is perpendicular to plane ABI, but CD is a line contained in the plane BCD. Thus, we can say that the plane BCD is perpendicular to the plane ABI. Application 2. In the adjacent figure, we have ABCD is a rectangle of center O. SB is perpendicular to the plane ABCD. Show that line AD is perpendicular to plane SAB. Please pause the video and give yourself some time to think. Well, we know that if line SB is perpendicular to plane ABCD, then it is perpendicular or orthogonal to all the lines contained in plane ABCD. Now, to prove that line AD is perpendicular to plane SAB, is AD perpendicular or orthogonal to SA, to SB, to AB? Well, AD is perpendicular to AB since ABCD is a rectangle. AD is orthogonal to SB since SB is perpendicular to ABCD by given, and AD is a subset of this plane. AB and SB intersect in point B, thus we can say that line AD is perpendicular to plane SAB. Part B. Deduce that plane SAD is perpendicular to plane SAB. Pause the video again and give yourself some time to think. AD is perpendicular to plane SAB as we proved in Part A. And AD is a subset of plane SAD. Thus, we can say that plane SAD is perpendicular to plane SAB. Please review page 309 and 310 on your textbook and solve exercise 21 parts A and B. The following summary summarizes all the main ideas we went over throughout the lesson. For any further questions, please contact your teacher. Thank you for watching.